In this video, I want to work through a hypothesis test for proportions. I've got another video that works through a hypothesis test for proportions, but it is a two-tailed test. In this case, I want to focus on a one-tailed test. And it doesn't matter whether you are working with a right-tailed test or a left-tailed test. This method and this example could help you with both of those. But if you're interested in a two-tailed test, then you may want to look at one of my other videos. So here is the example. In November of 2001, the AG Globetrotter newsletter reported that 90% of adults drink milk. A regional farmers organization planning a new marketing campaign across its multi-county area polls a random sample of 750 adults living there. In this sample, 650 people said that they drink milk. Do these responses provide strong evidence that the proportion is lower for this region? Well, this is a hypothesis test because I'm looking at a sample and I'm seeing if that sample provides evidence to support something or not support something. It's not a confidence interval. It's not a probability question. It's a hypothesis test because I'm looking for evidence. So the first step in a hypothesis test, at least the way that I teach it, is to write a parameter statement. And your parameter statement is basically the claim that you are trying to test. So in this case, if you look at this example, it doesn't say that the claim is. It doesn't specifically say the claim is this or the farmers claim this. But look at the question itself. It says, do the responses provide evidence that the proportion is lower? And that's the key right there. When it says the proportion is lower, that sets up the claim that I'm trying to test. So in this case, I'm going to say I will test the claim that the proportion of adults that drink milk in this region is less than 90%. And those two little words, less than, are going to lead me to write a null hypothesis or null and alternative hypotheses like this one. Less than tells me that my alternative hypotheses should look like this. The proportion is less than 0.9 or 90%. And that right there is the claim. I like to label the claim that I am testing. And if my alternative hypothesis says the proportion is less than 0.9, then that means that my null hypothesis has to say that the proportion is equal to 0.9. Now, some textbooks and some teachers will allow you to write, instead of just equal to in your null hypothesis, it would be okay to write the proportion is greater than or equal to 0.9. Because your alternative hypothesis says the proportion is less than, it would be acceptable to say that in your null, the proportion is greater than or equal to 0.9. So in this case, I went ahead and used just equal to because the original problem says that this newsletter reported that 90%. It didn't say more than 90%, so I went with that. And we're testing to see if it's less than. Well, we now need to check our assumptions and conditions. The first assumption and condition that we need to check for proportions is randomization. So in this case, it tells us that the sample was collected at random, and that means that this condition has been met. Then we get to the 10% condition. We want to know that our sample size is not more than 10% of the entire population. So I'm going to go ahead and say that 750 people is certainly less than 10% of all the people that live in this region. I would hope that there would be more than 7,500 people living in a collection of counties that are in this region. And then finally, for proportions, we have to check the success-fail condition. And we want to check to see if there are going to be at least 10 successes and 10 failures. So N times P, our sample size, times our P, our population proportion, 750 times 0.9 is 675, which is more than 10, and N times Q is also equal to 10. So once we realize that our assumptions and conditions have been satisfied, then I move on to naming the type of test that I'm going to work with. So here we go. The assumptions and conditions are met, so I can conduct a one proportion z-test with my alpha equal to 0.05. After we decide and name the test that we're going to be working with, we need to find the test statistic. And the formula to find the test statistic for proportions is this one right here. We take our sample proportion. Let me grab a different pen here. There we go. We take our sample proportion and subtract the population proportion. And the population proportion, by the way, is always the value that's up here in our null hypothesis. Sometimes students get that confused, but that the capital P is the proportion that is in your null hypothesis. And by the way, it would be a mistake to write P hat in your null and alternative hypotheses. You're always testing the population parameter. So you never want to put P hat in your null and alternative hypotheses. And then we divide by, down here back to our test statistic formula, we divide by the standard error. And I want to point out that the standard error for a hypothesis test, we want to use P and Q, the population parameter that was back up here in our null hypothesis, 0.9, and then Q, its complement, which would be 0.1. We do not want to use P hat here or Q hat here. Now, we did use P hat and Q hat when we were working with confidence intervals, but once we move to hypothesis testing, we are assuming that this null hypothesis is true. And because we are assuming the null hypothesis is true, we then need to assume that we can use that value in the null hypothesis for our population parameter. So now that we've set up this test statistic, let's go ahead and find it. Well, we have to start with our P hat, our sample proportion. And the original problem told us that there was 657 out of 750, which is 0.876, that drink milk. So I'm going to just go ahead and reveal all of this, and I'll let you go ahead and check my math if you'd like to. But once you do all the math, you find that your test statistic is negative 2.81. Well, once you find the test stat, you're going to use the test statistic to go ahead and then find your p-value. So I want to go ahead and find the p-value right now, and I'll go ahead and draw the picture what it would look like over here. Negative 2.18 is going to be somewhere over here, and I want to try to find the area below that. I know that this is a left-tailed test because of the way that I set up my null and alternative hypotheses. Whenever you have an alternative hypothesis, excuse me, that says less than, the less than symbol in your alternative hypothesis lets you know that this is a left-tailed test. Now, if my alternative hypothesis said greater than, it would be a right-tailed test. And if my alternative hypothesis said not equal to, that would be a two-tailed test. And like I said at the beginning of the video, I've got another example that is an example of a two-tailed test. But this is a left-tailed test because of those symbols. So now I can jump to my calculator, and when I use my calculator, I would type in, well, let me grab a different pen here. I'll go ahead and pull up my calculator real quick. There it is. In my calculator, I'm going to use normal CDF, so second vars, and go to number 2, normal CDF from negative 99 to, whoops, wrong symbol there, to my test statistic, which is negative 2.18. And when I hit enter, I get a p-value of 0.014 or 0.015, depending on how you want to look at it. So here we go. Let me minimize my calculator, and I get a test statistic, or a p-value, excuse me, p-value that is equal to 0.0146. And remember, I always want to compare my p-value to alpha. Well, my alpha, if you remember at the beginning, was 0.05. So it's pretty easy to see that my p-value is less than alpha. Okay, that's what I'm looking at. So M in my process stands for make a decision about the null hypothesis. And I can see that according to the model, since the p-value is less than alpha, I will reject the null hypothesis. So I am going to, my evidence does not support this null hypothesis. I'm rejecting it. Well, the nice thing about writing the claim as either the null or the alternative and writing which one the claim is a part of is the fact that once I realize I'm going to reject the null hypothesis, that tells me that my evidence supports the claim. So let's go back down to the very end. And S in phantoms stands for state your conclusion about the claim. So since I'm rejecting the null hypothesis, I would say this. There is significant evidence to support the claim that the percentage of adults that drink milk in this region is less than 90%. Now I want to point out that my very first step, P, which stands for parameter statement, is very similar to S, my conclusion. I will test the claim that the proportion of adults that drink milk in this region is less than 90%. And down here, there is significant evidence to support the claim that the percentage of adults that drink milk in this region is less than 90%. So there's a quick example of how to conduct a hypothesis test for proportions. I hope this helps, and have fun in your stats class.